Welcome to the another mensuration series where visualizations clarifies concepts. In this video, we will go through 3 questions on composite solids. Our first question. A solid consists of a cylinder of base radius of 2.5 cm and a height of 8 cm and a cuboid with dimensions 11 cm by 7 cm by 3 cm. Find, in part 1, the volume of the solid. Part 2, the total surface area of the solid. Let us recall the two methods that can be used to find volume of composite solids. We can approach the question directly by accounting for the volume of individual solids that make up the composite solid. Or if the solid is a prism, find the area of its uniform cross-section and use the volume of prism formula. Since the solid in this question does not have a uniform cross-section, we will proceed in favor of method 1. Calculate the volume of the individual solids and then add them up. The solid is made up of a cylinder and a cuboid with the dimensions as shown. Substituting into the respective formula for volume of cylinder and volume of cuboid, we have volume of cylinder calculated as 50 pi cm3. Volume of cuboid calculated as 231 cm3. Volume of the solid is therefore 388 cm3, corrected to 3 significant figures. Part 2 of the question asks to find the total surface area of the solid. Let's take a moment to account for the surfaces of the solid that can be touched. The orange rectangles account for the front and back faces of the cuboid. The yellow rectangles account for the left and right faces of the cuboid. One purple rectangle accounts for the bottom face of the cuboid. Notice that the top face of the cylinder and the top unblocked surface of the cuboid contributes one purple rectangle. Finally, the red rectangle accounts for the curved surface area of the cylinder. Now we are ready to calculate the total surface area of the solid. Taking stock of the different types of rectangles, we have 2 orange, 2 yellow, 2 purple, and 1 red rectangle. Carefully transfer the respective dimensions of the rectangles. If using colors is not possible in your daily work, you could label the rectangles on the main diagram and make reference to it. Adding up the 4 areas, the total surface area of the solid is 388 cm squared to 3 significant figures. Our second question. The figure shows a solid trapezoidal prism with a cylindrical hole of diameter 30 cm. Given that AB equals to CD equals to 40 cm, PQ equals to SR equals to 88 cm, PS equals to QR equals to 25 cm, AP equals to BQ equals to 74 cm, and the height of the solid is 70 cm, find in part 1 the volume of the solid. Part 2, the total surface area. Firstly, the solid is described as a trapezoidal prism with a cylindrical hole drilled through. What is a trapezoidal prism? Actually, a trapezoidal prism is simply a prism with a trapezium as its uniform cross-section. Likewise, a cylinder is a prism with a circle as its uniform cross-section. Using the formula of volume of a prism and substituting the values into the formula for area of trapezium and circle respectively, we have the parallel sides of the trapezium as 40 and 88, the height of trapezium as 70, radius of circle as 15, and length of prism marked in light blue as 25. We have the area of the cross-section as 4480 minus 225 pi cm squared. Take note of this value for now. You may need it later. The volume of the solid is calculated to be 94,300 cm3 corrected to 3 significant figures. Part 2. Find the total surface area of the solid. Once again, accounting for the different surfaces, which is easier to do by considering the net of this solid, we have the green rectangle that accounts for the top surface, the two orange rectangles that account for the left and right surfaces, the purple rectangle that accounts for the bottom surface. The yellow figures account for the front and back of the solid. Remember to include the red rectangle, which accounts for the curved surface exposed by the cylindrical hole. Taking stock of all the surfaces, the total surface area comprises of one green rectangle, two orange rectangles, one purple rectangle, two of the yellow figures, and the red rectangle. Substituting the values, we have the calculations for the respective areas. It is noteworthy that the area of the yellow figure was calculated earlier to be 4,480 minus 225 pi cm squared in part 1 of the question. Realizing this, you will not need to spend time calculating the area of the yellow figures all over again. Have you written it somewhere in your working? I hope this encourages you to have clarity in your maths presentation. Continuing with the calculation, we note a second interesting observation. Notice that the first three terms have a common factor of 25. Is this a coincidence? What is happening here? Factorizing 25 out, the sum of 40, 2 times 74, and 88 is actually the perimeter of the trapezium. This has great impact. This means that the total area of the green, orange, and purple rectangles could be calculated by perimeter of cross-section times length of prism. Lastly, as usual, the length of the red rectangle is calculated from the circumference of the circle as shown, which is expressed as 2 times pi times 15. Evaluating the numbers, the total surface area of the solid is 16,800 cm squared, rounded to 3 significant figures. Our last question. A C-shaped solid with an internal radius 6 cm and a uniform thickness of 1.5 cm has a height of 8 cm. Find part 1, the volume. Part 2, the total surface area. A quick question at this junction is to ask ourselves this. Can we approach the question using method 1, the direct method, or method 2, treating it as a prism? It turns out that this solid qualifies as a prism and therefore both methods are feasible. Pause the video here to look at how these two methods calculate the volume of the solid. The solid is actually half the volume of a hollow pipe. Going ahead with method 2 and approaching the solid as a prism, the prism's cross-sectional area is half a ring, which can be calculated as half the area of the yellow circle minus half the area of the green circle. Substituting the values respectively, we have the area of the cross-section as 10.125 pi cm squared and the volume of the solid as 254 cm cubed to three significant figures. Finally, we calculate the total surface area of the solid. Let us refer to the cross-section as the shape that looks like the letter C. From the diagrams, we can visualize the front and back surfaces of the solid as two C's coming together, combining to form one complete yellow ring. The area of the cross-section has been found earlier as 10.125 pi cm squared. Thus, the ring area is twice of 10.125 pi cm squared. The rest of the surfaces form a rectangle with its length as the perimeter of the cross-section and its breadth as 8 cm. What looked like a complicated problem ends up reduced to one of finding the area of a ring and the area of a rectangle. The total surface area of the solid is 427 cm squared, corrected to three significant figures. We've come to the end of the video lesson. Hopefully, you have gained more confidence in handling questions on volumes and surface areas of composite solids. Do pause the video to read through the lesson summary points. If you need to, go through the video again to look at the respective working. See you in the next video.